Okay, good morning, everyone. Now, if you may have noticed in Moodle, there is a new section which I've titled, I could have given it a number of different titles really, but I've just stuck with bundling or code splitting. Code splitting is really a subset of bundling, but we'll see how they're related in a while. And as usual, can I just check to make sure people can hear me okay?
Yeah, you're fine.
Yeah, I can hear you.
Yeah.
Right, so bundling is actually something we've been using from the outset in the web app dev module. And the bundling tool that we've been using is one called Webpack. It's been there in the background. By that I mean we've been using the Create React App tool to facilitate our React development, but Create React App actually uses this tool called Webpack internally. And so that's why I've given Webpack the kind of headline in this set of slides rather than Create React App. Webpack is used in by other frameworks as well, other single page app frameworks, and it's used more generally for any type of browser-based web app development. It has competitors though, but I'd say Webpack is probably the leader in its area. And so I'm saying there it's a build tool or workflow tool. Build tool probably makes a little bit more sense to us, but it's all about build automation and specifically for web app development. I could have really talked about this topic before I talked about continuous integration, either way. Because we, like in continuous integration, what we do in a continuous integration environment is we build our application. Continuous integration is useful for any type of application development, including web app development. But continuous integration, a big part of it is about automating the build process. And so Webpack fits nicely into that whole area of build automation. Now, what I'm showing you from the screenshot here, and I'm kind of reinforcing this idea or repeating this point that Create React App uses Webpack internally. And so on the left there, you may, well, you probably would have noticed it maybe from last week's stuff, but even before last week, it existed, this build folder on the left there. We never went near it, but what Webpack does is it actually creates that build folder and it populates it with various files based on our source code. On the right, what I'm showing you is, and really this is what we've been doing in the CI above in GitLab. We've been running a web server. It can be any web server, but we ran HTTP server, and we've pointed the HTTP server to our build folder. And so that must mean that the build folder contains our React app in some alternative kind of form. By alternative form, I mean alternative to the source code form. Okay, so it's again kind of by way of background. It's even when we were running the Create React App dev server, like when we typed npm start from the command line, it was actually using Webpack for that as well. But we mainly kind of associate Webpack with building our web app. So kind of formally, what I'm saying is that Webpack is a module bundler. And a module here now is essentially a JavaScript file. Each JavaScript file we classify as a module. It actually goes a little bit broader than that. Each CSS file is a module, or if you have static image files, they're modules as well. But let's keep it simple and just say that each JavaScript file is a module. And so what Webpack does is it takes all of the JavaScript files that make up your web application and it packs them or packages them into a one or maybe a smaller number of JavaScript files, which we call bundles or chunks. In other words, kind of it takes all of your source code and it bundles it into a single JavaScript file, or maybe 2 or 3 JavaScript files. You can control how many bundles it creates from your source code. And the way it does it is, I'm saying here, is it's all about analyzing the dependencies amongst your JavaScript modules. By dependencies, I mean what files import other files. I mean, if we flip over to VS Code just for a second, here's my movies app. And in the source folder, the kind of file at the very top of my set of JavaScript files is sorry, no. It's going to collapse all of those. Is this guy here? Okay, that's the JavaScript file at the top of my.
So you can't piece it.
Okay, I'm going to collapse that as well a little bit. Index.js is at the top of my set of JavaScript file hierarchy, if you like. And in that file, as you can see on the right there, I'm importing some of my other source codes as well as the React stuff. And if I looked inside in these files, they would be maybe importing other source code files of mine. So we have this notion of a hierarchy of JavaScript files, and there are dependency relationships between them, right? So what Webpack does is it takes the JavaScript file at the top of your hierarchy of JavaScript files, and it follows the import statements. And that's how it actually gathers up all of the source code that makes up your web application. Now, so we call these things dependency relationships. Okay, these import statements reflect dependency relationships between our JavaScript files, JavaScript modules. So it analyzes the dependencies amongst your web apps modules, and it outputs a packaged version of the app, which we call a bundle. Modules, I'm saying, are essentially JavaScript files are modules, but CSS files, it kind of understands those as well, because again, if I flip back to VS Code, like I am actually referring to CSS files here. And is there another one? There isn't. But you know, like from looking at the other source codes, that I can actually import a CSS file from JavaScript. So it actually understands, it can follow those dependency relationships as well to build a kind of what's referred to as a dependency graph representation of your app. And what it generates then, I'm saying in point number 3 here, is it generates a static version of your app, and that's what goes into the build folder. And in the build folder, which we look at a little bit more detail, that's where your bundle files will exist. They're called bundles or chunks. Okay, in this point here, I'm just saying it understands multiple standards. Oh, well, yeah. In terms of JavaScript, the only way we have represented a dependency relationship between one JavaScript file and another is by using the import statement at the top. That import statement is really part of the ES6 syntax, but prior to it, there was a slightly different way of referring to other JavaScript files, and it was involved using something called the require statement. The require statement was part of what was called CommonJS. You may actually see Frank Walsh using the require statement instead of import when he's doing his node development. There's also something called A&D, which is really redundant at this stage. We don't use it anymore. I am saying that really Webpack is mainly for big projects, but you know, we don't have the time to develop big projects. You can use it in small ones as well, and we can illustrate all the aspects of Webpack in our small movies app. But where it really shines is when you've got large web apps, be they React apps or Angular apps or Vue apps or whatever other framework you're using. Webpack just comes as an npm install. Now we don't need to npm install it directly ourselves. The Create React App tool does that for us. So this is kind of a visualization of what I've been saying in the previous slide. On the left, we have our source code, let's say. And so what this is kind of telling me, let's, for simplicity's sake now, assume that our modules are just JavaScript. We don't have any CSS or any less files or Sass files or font files, etc. So this looks like the module at the top of my dependency hierarchy. And it looks like it's, if we looked at the, if we looked at the source code inside this, we would see that it imports this and it imports this. And if we looked at the source code for this, we'd see that it imports this and so on and so forth. Okay. So what Webpack does is it kind of starts here and it builds up this dependency graph, and it puts each of these files, each of these modules, it actually processes them. We can see like part of the processing would be convert any ES678 back to ES5. But what it also does is it removes any white space in these files. And anyway, on the output side, it creates a bundle. So it might be just a single JavaScript file that contains all of the code that you have over here. It bundles it into one unit. It also, as I said, it removes any white space. So we want this to be as small as possible. This is what is actually sent down to the browser at runtime. Okay, the browser never sees these source codes. It only ever sees this bundled version of your app, whether that actually be in development mode or production mode, as it turns out. But now, this is probably a slightly better representation, really, of what Webpack does, in the sense that it probably creates, well, it creates definitely a minimum of 2 JavaScript bundles or chunks, but we can actually control it so that it creates more than 2. We'll do that at the latter end of this set of slides. It probably also, well, not probably, it definitely also puts all of your CSS into a bundle on its own. And there may be many CSS files over here, and it may not be just raw CSS, you know, it might be a less file or a Sass file. And so that less file, as it goes through Webpack's processing, what Webpack will do is convert it or transform it back into raw CSS, because again, a browser doesn't understand Sass or less or any of these higher level forms of CSS. If you have a number of static images, then it'll put all of those into a bundle. So we refer to each of these now as a bundle or a chunk. And this is what is received by the browser at runtime when it's running your application. So Webpack takes all of this and it generates this. What am I showing you here? Well, I said that the Create React App tool, that's what CRA stands for there on top, Create React App, What it uses is something called React scripts, and React scripts is really what uses Webpack. And what I'm showing you here is an excerpt from the package.json. So when you type npm run build from the command line, the build task inside our package.json I'm showing you here. And what build does is it uses a package called React scripts. And if we looked inside in the React scripts package, we would see that it uses Webpack. So you're kind of removed, you're removed from using Webpack directly when you're using Create React App, but that's kind of the path. Create React App uses something called React scripts, and React scripts uses Webpack. Okay, what I'm showing you here on the left are the bundles, and specifically the JavaScript bundles. Maybe if I flip over to VS Code. Here's my build folder. And inside in the static subfolder is where all of the bundles are. And we can see from the folder structure, there are some CSS bundles. So this one and this one. I'll talk about maps later on, what the significance of them are. So there's two CSS bundles. And on the JavaScript side, there is this bundle, and there is this bundle here. Again, there are also map files which are significant. There is another bundle here, but that's actually what's referred to as Webpack bootstrap code. And what we'll find out in later on in this set of slides is that this bundle here, main dot some odd number dot chunk dot js, that bundle contains all of our source code. And if I clicked on it, that's actually my code. This is actually JavaScript on the right, but it's a minified. All the white space has been removed. And if you looked through it, you would find references to your actual source code. So if you had a variable in your source code called foo, you would find that somewhere here. The other one, this one up here, this one contains all of the node modules that you are using in your app. In our case, that would be React, React DOM, Lodash, Font Awesome, the actual JavaScript code associated with those third-party libraries. They are put into a separate bundle or chunk of their own. That's what Webpack does by default. It creates two chunks, one that contains your code, the other one that contains all of the node modules that are used by your React app. So it creates two JavaScript chunks or bundles. Now later on, what we will do is we will actually split this one, which contains our source code. We'll split it up into a couple of more bundles for efficiency reasons. Right. So anyway, so when you actually type that command from the command line, now we were actually doing this inside in our GitLab pipeline. So it was actually generating the build folder up in GitLab, and then we were running the HTTP server. So React scripts is the link between Create React App and Webpack, if you like. Okay, I'm going to talk about Webpack, even though I've said we don't see it directly or use it directly. We use it indirectly, but it's good to be aware of just some of the basic concepts and ideas behind Webpack. Like if I was teaching me this module maybe 5 years ago, 4 years ago, then we would be using Webpack directly. But the Create React tool took a lot of this stuff, which is kind of messy enough in fairness. It took that and hides that away from us for convenience. But from Webpack's point of view, there are essentially three concepts that you have to be aware of. One is called the entry point. And the entry point is the JavaScript file that is at the very top of your module dependency hierarchy. So in our case, that was the index.js in the SRC folder. You have got to tell Webpack where that file is, because it takes that, and then from there, it can take care of the rest. It can follow all of the import statements to find all of the other JavaScript modules that make up your app. So that's the entry point. That's straightforward enough. Then what it uses are, it uses something called loaders. And the loaders are what transform your source code into a form that is usable by the browser. So in our case, for example, we will have loaders, or we need to use loaders that transform JSX back to ES5, transform ES7, 8, or 9 syntax back to ES5. Equally, there will be transformers that convert SAS back to CSS. So all of that transformation is performed by what Webpack refers to as loaders. Loaders are just separate NPM modules as well. Again, we don't install them directly. The React scripts package takes care of all of that for us. And thirdly, Webpack uses something called plugins. And plugins, as plugins always do, they kind of extend the basic functionality of Webpack. Webpack at its core is only able to do this bundling and transformation. If you want your Webpack to do a little bit more than that, then you've got to employ a plugin to do it. And we have been using plugins in our React development as well, behind the scenes. So Webpack is something that you have to configure. If we were using Webpack directly ourselves, we'd have to configure it. There are three ways that you can do it, but really the most common one is number 3 there. You provide it with a configuration file, surprise, surprise. The configuration file by default has this name. So when you start up Webpack, if you started up Webpack from the command line, which essentially we do when we run the npm build script. But what Webpack does is it goes looking for this file, and if it doesn't find it, well, it just bombs out. So that is the configuration file by default that Webpack goes looking for. Now notice it is a JavaScript file. It's not a JSON file. That's just kind of by the way. So it is actual code, but it's code that the Webpack tool can interpret and execute. And just by way of kind of proving to you that I'm not making all of this up, if you actually look inside the node modules, what I'm showing you here now in this screenshot is I've gone into the node modules subfolder in my movies app project, and I've looked for a package called React scripts, and there you see it there. There's my React scripts. And when I looked inside this module, lo and behold, I found a file called webpackconfig.js. So that is the actual Webpack configuration file that we are using every time we run npm build, or even when we run npm start, it's actually being used as well. Now you can actually dig down into your node modules subfolder of your movies app project, find React scripts and find this. and you can look at it. It is a JavaScript file. It's actually quite a long file. Now, if we didn't have create React app and we didn't have React scripts, we would actually have to write this ourselves. So we're spared that headache. So that again is kind of by way of background, just to prove to you that Webpack is pretty central to everything that we do in React development if we're using the CRA tool. If we just park Webpack for 1 second and talk about something called source maps. What I'm saying here is that source maps, you see, the actual code, JavaScript code that is sent down to the browser are these bundle files. And I showed you what a bundle file kind of looks like. And it's completely unintelligible to us, even though that is all JavaScript code. That means that if our app throws an error in the browser, then the error message, when we open up the developer tools, the error message will refer to a particular line number in our bundle file. This is, for example, one of the bundle files that the browser would have received. And so the error is telling me that there's an error on line 883 in this file. And we saw that was one of the actual bundles or chunks that was generated for our movies app. And this is the error. But of course, this is no use to us. We can't actually debug it. What we want is to be told, where is the error in our source code file? And we can debug it then. Now, what source maps do is they actually transform this type of error message to something that we can actually understand. So yes, we have a file called homepage.js. We're told to go to line number 5, and that's where the error is. So source maps, their purpose is to go to the top. They map a bundles file back to the source module on a kind of line by line basis. And on the right here, I'm showing you that these maps come in the form of an actual file. So for every bundle associated with your build, for every JavaScript chunk or bundle, there is a corresponding map file that accompanies it. And the map file is sent down to the browser with the bundle. And the purpose of the map is, as I said, to transform or to map any kind of error messages back to the corresponding source code file. Fortunately, Webpack generates these map files for us. Again, there isn't really any point in looking at the internals of a map file, although you could, it's an interesting read really as to how they're generated, because Webpack has to actually generate these map files. So there's nice theory there, okay, but we don't need to worry too much about that. We just need to be aware of what is the purpose of these map files and just leave them as is. There are different types of map files that you can generate. Again, this would be an issue if we were actually configuring Webpack ourselves. So you can have the map code, if you like. You can have that included in the JavaScript chunk or bundle, or you could have it as separate files. These are the two options that I'm mentioning here. There are other options as well. So clearly, this is the option. It looks like this is the option that Webpack is using for us, because we see separate map files in our build folder. So again, that's just by way of background. So just be aware of what are source maps and what is their function. I said Webpack uses loaders, and I've already kind of mentioned what the purpose of the loaders are. They actually do the transformation of your source code into a form that is usable by the browser. So I don't think there's a whole lot new in this slide, actually. It's a bit repetitive, but I'm just reinforcing that this is what the function of the loaders are. And if you looked inside the Webpack configuration file, you would find a loaders section. And essentially in there, what you have to do is you have to indicate what loaders you are using as part of your Webpack configuration, and what each loader is responsible for in terms of which modules does it have a role in. Some of the loaders are responsible for taking JavaScript files and transforming, let's say, the JSX back to ES5. Other loaders are responsible for transforming ES7, 8 JavaScript syntax back to ES5. Other loaders are just responsible for processing SAS files and taking the SAS and transforming it back to CSS. Other loaders are responsible for just processing less files and transforming the less syntax back to CSS, etc., etc. So you express that in your Webpack configuration files, i.e. what loaders you are using and what each loader is responsible for processing, which modules it's responsible for processing. I've kind of already hinted at this. When we talk about module dependency relationships, we think mainly in terms of a JavaScript file having an import statement referring to another JavaScript file. But Webpack is actually broader than that. It understands lots of different types of dependency relationships, and I'm kind of listing them here. So I've kind of already alluded to this anyway, but Webpack treats every type of file as a module. So CSS files, you may have specific font files as part of your source code. You may have image files as part of your source code. This is part of your source now, not the images that you might download at runtime as we do from the TMDB. They're not part of your source code, but if you had static images maybe as part of your web app, those images, as far as Webpack are concerned, each image file is a module. So it actually understands all of these different types of modules. It can follow lots of different types of module dependency relationships. It can obviously follow JavaScript import statements, but it can also follow import statements that might appear in your CSS. You probably know that you can have one CSS file referring to another CSS file by means of an import statement, or in fact by means of a URL kind of reference. And Webpack can follow those. And by follow them, I mean it can include the other CSS modules that are being referred to as dependencies and bring them into the CSS bundle, and so on. What we actually do, as you've seen, is we import CSS from our JavaScript. It knows how to interpret those, and so on and so forth. Images, fonts, which we don't use in the case of the Movies app anyway. So it's pretty broad in terms of its understanding of what constitutes a module, and it is able to follow lots of different types of inter-module dependency relationships. And the purpose of it all is so that it can build its bundles so that the bundles contain absolutely everything that is needed by the browser in order to render your app. So we're back to here again, kind of we've seen this before, I know, but so now we know that these bundles, this might be the bundle that contains all of my source code. This might be the bundle that contains all of the node modules that I'm using. This is the one that contains my custom CSS, as well as, let's say, the Bootstrap CSS, because I import the Bootstrap CSS. So it's all going to be inside in that bundle. I don't have any image bundles in my case, or in the case of the Movies app. Okay, not too sure that this is the, excuse me, this is the kind of old form of importing in JavaScript, the require statement. That statement is essentially the same as this kind of more modern import statement. It has the same purpose, but Webpack understands this and it understands this. From a CSS point of view, it understands import statements like this in a CSS file or like this. Quick little bit about plugins. Some plugins come with Webpack. They're kind of built in, but there are lots of third-party plugins, and lots of the JavaScript community out there have built useful plugins for us over the years. So again, that's just by way of background. Plugins are installed as NPMs. We use plugins in our React development, or maybe I should say that the React scripts module uses plugins, but it takes care of installing them for us. I'm just mentioning two here. This plugin, every time we do an npm run build, what needs to happen is the current contents of the build folder needs to be cleaned out completely. And so there's a plugin that does that, which is this plugin here. This plugin, what it does is it actually generates the index.html for your kind of build version of your app. In other words, if we look inside the build folder, this file here, that's actually generated by a Webpack for us, and like it's actually a single line, but it scrolls right over. But if you scanned right across here, right, what you would find is references to my JavaScript bundles and my CSS bundles. Okay, so it has to, this index.html has to contain references to the bundles that need to be downloaded to the browser in order to run your app. So this plugin here, this plugin actually generates that index.html for us, which is kind of convenient. Now, what bundling is really all about is it's really aimed at constructing or creating a production, what I'm calling a production version of your web app. It's all well and fine when we're doing React development and we're doing npm start, and we know that when we type npm start, it starts up a special web server, development server for us, and it has all of that useful stuff like live reloading, etc., and retranspilation of our code whenever we change it. And that's great during development mode, but that's no good in production mode. So bundling is really all about developing a production version of your web app. And a key objective when you are building a production version of your web app is to try and make sure that the actual initial load time, what I'm calling here the load time performance of your web app is as good as it should be or can be. We don't want, when a user tries to load our web app into the browser, we don't want them sitting there waiting for the app to get up and running. We'd like that to be as quick as possible. And how do we kind of achieve that, or what are the different ways of trying to ensure that the load time performance is as good as it can be? And I've kind of alluded to some of them already. One is make sure that your bundle files are minified. Minified means any white space is removed from them. Uglified is, well, one aspect of uglification is, you know, when we write source code, we like to have meaningful variable names, and sometimes the variable names can be quite long, so that they are clear to other people that would be reading our source code as to what is the purpose of the variable. Similarly, with function names and class names, we like to have expressive names. Now, from a bundling point of view, like the browser doesn't really care about meaningful variable names. What would be useful is if any kind of long names that we introduced into our source code, they could just be reduced to very short names, meaningless names really, from a human point of view, but the browser doesn't care about meaning for variable names. So uglification is this process of, you know, actually renaming lots of entities and constructs within your source code back to very short names. That's just part of uglification. So those two things, and what's the point of maybe reducing the actual length of a variable name? Well, it just means that your bundle size is going to be smaller. That's the aim, really, to make your bundles as small as possible. I probably should have said that back here, really. The smaller your bundles are, the shorter they take to get transferred across the network from the server to your browser. Okay, so the purpose of these two is to make your bundles as small as they possibly can be. Caching is obviously a good idea from a load time performance. Like every time we load, I load a particular web app into my browser, then if the browser has already loaded that app recently and it hasn't been changed back at the source level, then maybe the browser should cache the various bundles locally, and then it doesn't need to actually request them from the remote server at all. Equally, any kind of intermediate devices between my browser and the actual server that is hosting my web app, whether that be Heroku or whatever other cloud server. We haven't done any hosting or deployment admittedly yet, but we can imagine that our web app is being hosted on some server somewhere in the world. And if if I've loaded that particular app into, or if a person has loaded that app into their browser and the app code hasn't changed, then subsequent loading of the app into the browser should avail of caching, whether that be it's cached in the browser or it may be cached in intermediate router devices between the browser and the server. But caching is really a very useful aid to load time performance. Code splitting is really where we will come in this process here, because really Webpack takes care of all of minification and uglification for us. These two are switched on kind of automatically. It actually takes care of, Webpack takes care of caching as well for us, as we'll see in a while. But what we have control of as the developers is something called code splitting. And that's really going to be the significant part of this whole set of this topic, really, from our point of view. And you may or may not remember that code splitting is one part of the assignment that I gave you in this module last week. So we're getting close to that. Another way of what I'm really trying to say here is we're trying to optimize the bundling of our web app. That's the purpose of this whole slide here, optimization. Now, time-wise, I wasn't really expecting how to get through all of these slides today, so I'm not concerned about that. We've kind of already seen this, right? From a minification point of view, we've seen that the bundles, the JavaScript bundle that Webpack generates are indeed minified. No white space in them at all. So that's that taken care of. We don't have to worry about it. So from a caching point of view, how does Webpack help? I've already said what caching is all about. We know what caching is about, and loads of devices on the network out there support caching. Okay, so CDN supported, ISP supported, various router devices supported, the web browsers themselves, they support caching. So it's up to us as the developers to utilize the caching that these various networking devices support. And how do we actually do that? Well, it's actually quite simple, really. You see, what we've got to ensure or try to ensure is that if a bundle has not changed recently, then these various devices, if they've already cached the bundle, then they will know I don't need to get that bundle again from the host server because it hasn't changed. But how do these devices, including the browser, how do they know whether a particular bundle has changed or not? And the answer lies in the actual naming convention that Webpack uses for the bundles. Now, do I mention it here? Oh yeah, I'm seeing it here actually. So Webpack uses hash-based file naming formats for its bundles. And how it breaks it down is, for each bundle, there is a bundle name, then there is a hash value, and then there is the string chunk.js if it's JavaScript. This hash value here is computed by Webpack at build time, and the hash value is based on the contents of the bundle. So if you haven't changed your source code, then this hash value hasn't changed. And if any of these devices up here already have this particular bundle, then they know they don't need to re-request it. They have it locally, and they could send it back to whoever has requested it from them. Okay, so this hash-based naming convention is the key to leveraging caching from Webpack's point of view. And I'm not sure if you've covered caching to any degree in any of the topics. We know what the basic idea is, so maybe we don't need to dig into it any deeper than that. So from a Webpack point of view, just be aware of what the meaning of this hash value is in a bundle or chunk file name. How it's computed and what its purpose is, and its purpose is to support caching. If I just go back to here, just to make sure we're kind of clear on that now, because I'm not sure if we look in the index.html, which we have here. Now, inside in this index.html, it's kind of hard to prove it, but you can do it later yourself. But if you look inside in this index.html and it scrolls all the way over, then you will find a reference to, let's say, to this chunk and to this chunk and to this one. The only ones we're really interested in though are this one, which contains our source code, and this one, which contains the node modules that we use. So inside in the index.html, it will have references to those in the normal HTML syntax. So that means if I've got a browser and it loads this index.html into the browser, because the index.html contains references to other assets, in particular our JavaScript bundle assets, then, and if this is the first time I've loaded this index.html to my browser, the browser is going to request those assets from the hosting server. The hosting server returns them back to the browser. The browser will now actually store them in its cache. The next time I come along and I try and load this app into my browser, okay, the index.html will load up. In the index.html, it will have references to two other assets, my two JavaScript assets. It'll first check though if it has those already in its cache, and it does, so it just loads them straight away. Now, every time my browser loads this index.html, the actual index.html is sent to it by the hosting server. So it's only the hosting server knows whether something has changed or not. If nothing has changed back at the hosting server will send the index.html. Once the browser has received the index.html and then it goes trying to access the bundles, it will see that the bundle names haven't changed. And so it will check its local cache and it will have them and it will just load them straight away. If by chance the actual application source code has been changed in the meantime, when the browser requests the index.html from the hosting server returns the index.html back to the browser. But of course, now the bundle chunk hashes have changed and the browser will no longer have those in its local cache. And so it will actually request them from the hosting server. Okay, that's kind of how the caching will work at the browser level. And the same type of process goes on for all of the other intermediate kind of routing devices like CDNs and ISPs and routers, etc. But of course, none of this works if we don't follow this kind of naming convention. If my bundles were just called main.js, then there's no way for the browser to know whether the actual bundle has changed or not. Right, I'm going to freeze it there and pick up this stuff with you next week, which kind of means for the labs next week, I would like you to work really on your assignments, be it the Agile one or the web app one. I'm still going to hold meetings for the app, for the labs. So if you've got any questions in terms of points of clarification, I would have expected 1 or 2 questions from you in relation to points of clarification for either assignment, but maybe not. Maybe I made it clear as to what exactly I'm looking for. But anyway, I will schedule meetings next week for the various lab hours for the Agile module anyway. And but the understanding is that you can use the time to work on your assignments and ask me any questions that you might have. Okay, that's it for today, I think, unless there are any closing questions from you. No. All right, I'll talk to you on Monday in that case. Bye for now.